All right, here's our Chapter 5 test review. Answer key video. Please follow along, make corrections as you need, and we will get started now. For the first two, I'm finding the unit rate. The unit rate is simple to find, right? We are trying to find, instead of on 10 gallons, we are trying to find on 1 gallon. Okay. Miles, we are trying to find on 1 gallon. Easiest way to do that is we're going to take 289 and we're going to divide it by 10. 289 divided by 10 is 28.9 miles on 1 gallon. Typically, we would see this written something like this, mpg, miles per gallon. Second one, again, I'm going to take my cost, 48 cents, and I'm going to divide it by those 6 ounces. This is going to give me 0.08 per 1 ounce. Those would be my unit rates. Again, unit rates always compare to 1. For number 3 and 4, I'm proving whether these form a proportion or not. All right. So we can take a look like this. And I'm going to make these into fractions. If they are proportions, then we know that they are equal. And we have a bunch of different ways to check that out. One way of doing that is doing some cross-multiplying here. When I cross-multiply, these will be proportional if I get the exact same answers. All right, 8 times 1.2, that's going to result in 9.6. 3.2 times 3 is also 9.6. Since they match, we would say this is yes, it performs a proportion. All right, for this one, I have 12 over 16, and then I've got 8, and then we're actually going to make a complex fraction here, 8 over 32 thirds. Again, we're going to set these equal to each other. I personally just like doing the cross multiplying. It makes sense. It works a lot for almost everything. All right, 16 times 8 on a calculator, if you do that, is 128. Next up, we've got this 12 over 1 times 32 over 3. Right, this can be simplified down a little bit. 4 times 32 also happens to be 128. So we would also get a yes, this is proportional here. Okay, number 5 says, write the ratio of water to flour, then find the unit rate of the ratio. To write a ratio, I'm just going to take my cups of water with a label, put my dot in the middle saying, hey, this is 2, and we've got 2 cups of flour. There's my ratio. To find our unit rate, well, we already know my unit rate has to be this, and I can think to myself, in order to go from 2 to 1, I got to divide by 2. So I'm going to divide 3/4 divided by 2 over 1, which can be also written as 3/4 times 1/2, and I get 3/8. And we would say 3/8 cup of water for every 1 cup of flour. That is my unit rate. All right, number 6, we've got a ratio table to look at here. In ratio tables where I've got fractions, I always like to kind of change some things. And I see that my top row has fractions over 2. Initially, I had this 3 in there, so 3 over 1. I'm going to want to try and get it to where it has a 2 on the bottom. This actually makes it so much easier to see our connections between them. Well, I can see that 1 times 2 would get me to 2. So in order to keep this equal, I do the same to the top. And I would end up with 6. So we can say, hey, this is actually 6 over 2. We're going to do the same with the bottom and change this 2 over 1 to have a 2 on the bottom, which both of these just need to be multiplied by 2, and we've got it. So this 2 is going to change into 4/2. Okay. Let's see. To fill in the table now, I can see that if I were to multiply the top here by 2, I would get to 6/2. So we're going to do the exact same thing on the bottom. 1/2 times 2 actually just ends up being 1. We can also write it, if we want, as 2 over 2, since that is a form of 1. And now this is actually really nice and easy to see what's happening. Right? Every single step of the way, I'm adding 1/2. adding 1/2, adding, or not, yeah, 1/2, and adding 1/2, meaning up top, I can do the exact same using the exact starting thing as well. This is plus 3/2. So my next one should also be plus 3/2. We can always check these as well to get 9/2. And again, we're gonna multiply. We're gonna add 3/2. And I get 12/2. If you didn't see that, right, we could have also done like 1/2 to 3/2 is times 3. 1/2 to 4/2 is times 4, which also matches up there. Okay. Number 7 says a train travels 10 miles for every quarter hour. What is the train speed in miles per hour? Well, this would be nice to just set up a little ratio table. Miles, hours. My initial one is 10 and 1/4. If I'm looking for miles per hour, I'm looking for how many miles in 1 hour. Meaning to get from 1/4 to 1, that's just going to be simply multiplying by 4. Doing the same here, I get an answer of 40. Meaning we would say that my train speed is 40 miles per hour. All right, last two for this page. I've got 8 and 9. Solving for x. Whole bunch of things we can do here. I'm going to do our cross multiply butterfly method and see that 4 times 2 is 8. 5 times x is 5x. I'm going to divide both of these by 5, and I end up at 1.6 for an answer. For number 9, I'm not even going to bother with that. I'm going to do the mental math here. I know 3 times 3 is 9. 8 times 3 is an option we can do. 8 times 3 is 24. All right, moving to number 10. We've got a question of, is this table proportional? How do we know? Well, we got a whole bunch of things that we could check. We could divide these two and find our unit rate down here. We could look at, hey, how do I go from one spot to another? If it doesn't match up, then we know it's a no. If all of them match up, we know it's a yes. I'm actually going to do that strategy because I can see, right, to go from 2/3 to 4/3, that's just multiplying by 2. So, on the bottom, I should be able to take 7/10, multiply it by 2, and end up at 1/2, but oh no, we end up with this like 1 2/5. That definitely is not 1/2. We would say no, and we could talk about unit rates don't match up, something like that, right? Showing this connection here does not end up working out. Number 11 says that the graph shows the cost for concert tickets. Find the cost per ticket. Okay, so for this one, we're gonna kind of set up a table that looks like this. I have cost and then ticket. And we can kind of look at the graph here and see. So I see that for 2 tickets, it's going to cost me $26. For 5 tickets, it's going to cost $65. And then for 9 tickets, it's going to be a whopping $117. If I'm looking for the cost per ticket, I'm looking for the cost per 1 ticket. And I can take any one of these values and divide it to get to 1, and I'll find out my cost. Easiest one for me, I see. Let's just divide 2 by 2 to get to 1. Right, that means I would take 26 and divide it by 2. We end up with this 13, which is going to be our cost per ticket. So we could say something like that. If you were to, to maybe divide by 5 here, divide by 5 here, you'd still get 13, as well as dividing by 9 and dividing by 9, we still get 13. So again, our answer, $13 per ticket. Finally, number 12 says plot the coordinates on the graph, tell whether x and y are proportional, and explain your reasoning. So, let's see, in order to plot these, we're going to take our x-y pair, like this, and we're going to say, oh, this one just doesn't go anywhere. It sits right there. My next one, we always say that X runs, Y rises. So we're going to go to 2 and then go up 1. And that is the point 2, 1. My next one is 4, 2. We're going to go over to the right 4, up 2. And finally, I've got this 6, 3. Go all the way to the 6 and up to 3. All right. I like to connect my lines just to see what kind of situation we've got going on here. All right. Our two things to tell if a graph is proportional, right? We need it to go through the origin and is a straight line. Well, guess what? There's the origin right there. So that's a check mark. And it was in our table originally. Also, we see it is a straight line, and this is confirmed by seeing that each of these are linear in the fact that they hop / grow at the exact same rate, top and bottom. Right, on top we're adding 2, on the bottom we're adding 1. This is a definite yes, and we could talk about how it's a straight line. Not line. It goes through the point 0, 0. All right, consistent in the table, all those things. All right, last two, we've got 13 and 14. 13 says you mix 1 quart of red paint for every 1/6 quart of white paint to make 3.5 quarts of pink paint. How much red paint and how much white paint did you use? Well, we're going to set up a nice little table here to help us out. So I've got red, white, and pink. It says I use 1 red, 1/6 of white, and I'm in total going to end up at 3.5. And we think to ourselves, how do we make pink paint? Well, we're going to add and combine white and red together, meaning I'm going to add these two, which would give me this 1 and 1/6. All right. Now I'm trying to figure out, well, how do I get to, 3.5? Well, first of all, what I would do is I would change each of these into improper fractions, right? 1/6 is going to become 7/6. 3 1/2 is going to become 7/2. I still, I could figure this out, but it's a little challenging with different bottoms. So let's go ahead and change the bottom to match. This would be times 3. So this is times 3, meaning I have 21/6. Okay. Now I can easily say, hey, how do I go from 7/6 to 21/6? Well, that's just going to be a matter of multiplying by 3. So to get from here to here, we multiply by 3. Meaning, if this is a ratio table, we also have to multiply by 3 here and multiply by 3 here. 1 times 3, that's nice. That's going to be 3. 1/6 times 3, that's going to be 3/6, which simplifies into 1/2. You're going to notice something, right? I've got 1s matching up, and then my 6 right there. It also does end up matching up right there as well. All right, so when it asks how much of each do you need, we will need 3 quarts of red, and then 1/2 quart of white. And that would be my answer. Right, number 14 says you paint 4 walls. Each wall is a rectangle with a length of 14, a height of 10. 1 gallon of paint covers about 350 square feet. How many gallons do you need to buy in order to cover the walls? All right, let's start with one wall. There's my beautiful rectangle wall. I have a length of 14, a height of 10. All right, since I'm dealing with square feet here, I know that I have to find the area, which is just length times width. 14 times 10 is 140. Next, I've got to take into the fact that I don't just paint one wall. I end up painting 4 walls. So if we had 4 identical walls, right, this one would be 140, this one would be 140, that one would be 140. All of those combined, if we add them, or you could just multiply 140 by 4, we end up with this 560 square feet. Okay. Now, I know that in one paint can, or 1 gallon of paint, right, this can cover 350 square feet. And what I'm going to do is I'm going to see, well, how many of these gallons am I going to need to cover my entire wall situation? All right. Let's say we just start with 1. I have 350. 350 is less than 560. I am not going to have enough by quite a bit. So I need more than 1. How about 2? Well, 350 plus 350, that's going to be 700. All right, 700 is bigger than 560, meaning I have enough to cover and then some. So how many gallons would I need? I would end up needing 2 gallons, just like that. All right, those are the answers for our review. Take some time, study it, and good luck on the test.